Hi folks, Brian Benz here. I'm a cloud advocate at Microsoft. Welcome to using AI to deploy Java apps to Kubernetes. Before we get started, I just want to say thank you very much to the organizers for allowing me to do this virtually. It wasn't anyone's first choice. I was quite sick last week and unfortunately wasn't able to make the journey there, but the organizers were kind enough to allow me to do this virtual presentation, and I hope you find it valuable and useful, and please do provide feedback, and I'll provide some slides as well or anything else you'd like. Thanks again to the organizers, and let's get going. So I mentioned I'm Brian Benz, cloud advocate at Microsoft. Been there about 10 years. And today I'm going to take you on a journey through um, taking an app from, I'm going to find something on Docker Hub, which I already picked it out, but, and we're going to use that to deploy to Kubernetes without anything else. We're going to have AI help us generate the deployment manifests. We're going to have AI suggest security improvements. And by the end, we'll have a hardened, deployable example that I can show you. I'm also going to show you, well, that's a very simple example, of an application that's going to be running, just a regular, simple, single-use application. I'm also going to show you an example of something a little more complicated using Open Liberty on Kubernetes as well, and how you would actually deploy that, and the things you can use AI for as well. So let's get started. Folks have probably heard a little bit about Azure and AI. It's really in the news these days. AI is just such a big topic. And there's so many amazing developments happening right now. I can tell you this morning I was in a meeting for our Microsoft Build conference in May. If you get a chance later on in May, do check out the videos. They're going to be online. There's some amazing announcements coming down the pike and some incredible developments that are happening with AI to make developers' lives easier. The reason I like this topic, deploying Kubernetes apps, deploying Java apps to Kubernetes, is because the as developers in general, we already know how to write code and we know how to structure code and build nice apps. But we don't know everything. And, learning things like how do you create a Kubernetes deployment manifest, or how do you actually build security into your application, and things like that. That's the sort of thing that might not be in your central area of expertise. If you're coding all day, it's very hard to keep up with everything else. So the great thing about AI is it sits there right next to you and helps you with the things you don't know. And here's an example of some of the things that you can use. Some of these have been around before OpenAI, including our bot service, which is used for chat, cognitive services for image searches, and for text searches, and for translating text, a form recognizer for basically taking any kind of form and putting it into something that can be interacted with, a video indexer. If you get a chance, check out the Azure Video Indexer. They have a free version. It's pretty cool. So you take a video like the one I'm recording today, you send it to Azure Video Indexer. It'll break it down into scenes. It'll identify people in those scenes. It'll identify activities happening in those scenes and help you sort of split it up. For example, when you're creating a video and you want to put a short video on one of the social media sites, it's a great way to help you build that. It's pretty cool. So we have a vision for images. One of the great things about having a cloud service for AI is there's a huge amount of data that you have to process. And we're finding more and more that customers want to have the data that they're using in their AI services, not necessarily in the AI service, but close to it so they can look things up. Then we have speech services. Speech is really amazing. If you get a chance, check out the Bing Translator. It's a free app, and I use it when I'm traveling. You can put it on the table in between some people who are speaking different languages. It'll detect all the different languages and actually translate in real time during a conversation. So that's pretty cool. So speech and language combined is, something that it goes into Bing Translator, but you can also build your own bespoke applications using the same facilities. And then there's decision making. I don't know. I'm a little torn about AI making decisions. I really think it's great for providing information and helping humans make decisions, but there are certain workflows and things that you could do. You can say, if, for example, it helps you create sort of virtual assistants that say, hey, if all the tests have passed on this code, move it to the next stage in your DevOps routine, things like that. And then, of course, last but not least, Azure OpenAI Service. I had it about a year now, and it's really kind of superseded all these other ones that I've described here, but they all work together in concert to actually help you build things. So that's our AI infrastructure in a nutshell. So one of the things I do want to talk about as well is Azure AI Studio, and it's a way to sort of build and train your own models. So people are using OpenAI, they're using ChatGPT, and we have a version of that called Azure OpenAI, which is used for our Copilot service, which I'm going to be highlighting today, and other services as well. By the way, my illness is still coming back every once in a while. You probably hear it in my voice, so apologies if my voice cuts in and out a little bit. Excuse me. Anyway, build and train your own models is what you can do with that. So you can do something called retrieval augmented generation, which is a way of taking your data, putting it adjacent to OpenAI data. And when you do a search, it's actually going to retrieve data from your information without sharing it with OpenAI. Then it's going to go out and get some information from OpenAI and bring them together. If I was there in person, I was going to show you a demo of a cool tool that I built. It's a little bit off topic for this, but it's not a Java app. It's just an app that I used building Azure using Azure AI Studio. And basically what it does is it takes my itinerary for my journey to Bangalore and it combines it with all the information about Bangalore that's in OpenAI. And that's my personal assistant. So I can ask it questions like, when do I get to Bangalore? And it'll tell me. I get there. Well, I was going to get there at like 1 a.m. And then I can say, how long does it take to get from the airport to my hotel? That's the question. So it knows from my itinerary in the retrieval augmented generation, the adjacent data, where my hotel is. And it knows what time I'm going to arrive based on my flight information. So the question about how long does it take to get to my hotel from the airport, it will imply I'm coming from the airport based on my previous question, and then it will imply that I want to get from the airport to my hotel, and it'll use the information it has about Bangalore to calculate how long it takes to get to my hotel. I don't have to tell it my hotel or the airport or any of those things. It actually figures everything out. That's retrieval augmented generation. That's a really simple example of combining those things together. So you've got a little bit of data that's personalized but not shared with the world on OpenAI. I don't want to share my itinerary with the world. But it also has the power of OpenAI to combine with that adjacent retrieval augmented generation data and build your tool. That data that's stored adjacent is stored in a vector database or a vector index. And there's a whole bunch of vector databases you can get. We have Postgres, Cosmos DB, and a few others on Azure, but there's several others as well. If you just search OpenAI vector databases, you'll see what's available. And then from that, you can create prompt flows like I just explained. So I said, how long does it take me to get to my hotel? And it understands that the previous question was, when do I get to Bangalore? So it knows I'm going to Bangalore. It knows the context from my previous question that I'm going to be at the airport. And it makes a whole bunch of assumptions about where I want to be. And then it uses the data from my vector database to bring in the rest. So that's pretty cool. So this is just actually describing what I just described, which is our retrieval augmented generation. You've got a whole bunch of data sources as well. So you don't have to provide your own data. You can have third-party data sources too. Files, database storage. Those of you who are familiar with Kaggle.com, Kaggle, will probably know about all of the great open data that they have there. All the data there is generally in some sort of shareable license. and it's public information, et cetera, that you can use to build and combine with your applications to actually build data and use that retrieval augmented generation to put that together. All right. So a Copilot for every Microsoft cloud experience. Yes, Microsoft, you've probably heard about Copilots. I'm going to show you GitHub Copilot today, but last count, I think we had 90 something Copilots, which obviously it's a lot. But apparently there's a use for each one of them. Hopefully they don't overlap too much. But here's some of the highlights that I like to use. When I built this slide deck, I asked it to add a demo slide for my presentation. I'll show you that demo slide in a little bit. And it just went out and it said, yeah, sure, I'll build the demo slide. And here's what I've got. Basically change it if you want, but it just created something simple for me. You can ask it to add an agenda and it'll go through your slide deck and build things like that. Dynamics 365, well, that's for customer relation management. And we also have Power Platform, which is our low code, no code platform, and some Copilots there to help you build. So it makes it even easier than low code, no code to actually build these. You can say, build me a workflow that does X, Y, and Z, and it'll actually build it for you. Microsoft Security Copilot. I'm running into this all the time. I write demos for a living, and if I'm writing a demo about Kubernetes and AI, it could very easily become a security demo if I created all of the security aspects that really lock down the data that you would want to have in production. So admittedly, I don't do all of them because I don't have a lot of time. I'm doing this presentation in 1 hour. And, it's important. Security is so important. Don't get me wrong. But if you're writing a demo in 1 hour and you might cut a few corners in terms of security just to highlight the actual service or product that you're working on rather than highlight the security capabilities that are built into Azure, which are extensive, but you don't always get to use every single one of them. So anyway, that's a long way of saying that I run into trouble with Microsoft Security Copilot a lot. The demo I'm going to show you today, when I deploy this, it's Cassandra. It's completely unsecure. And I'm going to delete it right away. And that's what you have to do basically when you're building these things is create them and then delete them right away. And obviously I don't expose any customer information or any personally identifiable information, PII. So there's very low danger, but Microsoft doesn't know that. Microsoft doesn't know I'm writing a demo. It just sees this insecure Kubernetes cluster and it's going to come out and warn me in very, very, very explicit terms that I need to fix that. Last but not least, today I'm going to be highlighting GitHub Copilot. So let's just dive into that. So GitHub Copilot is really cool. It offers code suggestions contextualized to your project. There's Copilot and Copilot Chat. So Copilot itself basically is sort of like an autocomplete, but you start typing like, it's really cool. If you're working with Java, create a new class and say, public class radius of a circle. And it will actually fill in a code for that class that will return the value that you're looking for. Extremely cool stuff. If you want to do documentation, you just say, please document this line, da, 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 and it actually completes the documentation for you. It fills in variable names. It knows everything about this document you're working on at the moment. So it's very cool. Copilot Chat is the next version of that. So Copilot Chat is even better in the sense that you can ask questions like, how would I make this code better? And it'll give you suggestions. And I'm going to show you how to do that later on today. I'm going to show you how to create Kubernetes. So I'm going to say, hey, here's something out on Docker Hub. How would I deploy this to Kubernetes? And it's going to give me step-by-step instructions on how to do that. So a bit of a spoiler alert, but anyway, I just wanted to tell you about that. Where can you use GitHub Copilot? VS Code, GitHub Code Spaces, which is our online version of VS Code. So when you go into GitHub and you click on the Code tab, which you might have seen before, there's now a new tab, which is Code Spaces. you can create a code space, which is basically, it goes out to something called a hosted runner on GitHub. It creates a clone of your repo in a container with a running version of VS Code with extensions and everything. And you can actually use that. And it works with Copilot. So it's very cool. Visual Studio, of course, we're Microsoft. So we're going to put that on Visual Studio. We're not going to miss that opportunity. JetBrains IDE. So if you're using IntelliJ IDEA, you can use all the features I'm going to show you today on that as well. And NeoVim, a little bit of a trivia question. What is the fifth thing that you could use GitHub Copilot for? It's NeoVim. So that is fully functional with GitHub Copilot as well. So what the heck is GitHub Copilot? Basically, we start with the OpenAI on the left. It takes context from the code you're working with at the moment. It provides suggestions for the code. It also provides chat, and it runs on all the IDEs I showed you just a moment ago, but here's the logos for those down along the bottom as well. So GitHub Copilot, what are the things that it is aware of when you're working with VS Code or other IDEs? It is aware of file names, open files, cursors, and selected items inside of a specific file or in the file system on the left and the Explorer on the left. So those are the things it knows about, and it'll make decisions. You can ask it questions and it'll make decisions based on those. Okay, inline completions as well. So inline completions, pretty cool. So you can say Control, Command, and Enter to get a list of suggestions. So if you don't like the answer that is given you right at this moment, you can toggle through all the suggestions using the keys that are shown there, Option and bracket, to navigate to all the possible suggestions. And then you can accept things, not the whole thing, but you can accept word by word using that key combination as well. And you can tab to accept suggestions as well. So that's pretty cool stuff. All right, so let's get into a demo. So we're going to start at the beginning, which is the Azure portal. So this is portal.azure.com. And I have created a couple of resources that we're going to use today. This square here is called a resource group. By the way, you can sign up at portal.azure.com if you don't have a subscription. If you do, you're probably already familiar with this screen here. But I organize all of my dashboards, this is a dashboard, into presentations that I do in different locations and things like that. The inside of this square here, which is a resource group, and it groups all the resources together, are a few things. I've got a Kubernetes service, which is basically blank at the moment. I've got a container registry. I've got a search service, which allows you to do some retrieval augmented generation. I've also got application insights and just some ways of connecting and working with different platforms and things, and an Azure AI hub. Okay, so today, though, we're going to focus on the AI for Java Kubernetes service. And let me just switch over. It's a blank service right now. There's absolutely nothing running in here. And what we're going to do is we're going to start with this. This is what a blank service looks like. It's even, it's got all of these namespaces and everything running to maintain the service. A little bit about Azure Kubernetes service. So it's Kubernetes. It is open source, and the control plane is managed by Microsoft. So you don't have to worry about updates, security, management, things like that. Well, you still have to worry about those things, but you can set them to be automatically configured by Microsoft if you want to. All you need to focus on really is putting your pods out into your Kubernetes cluster and running your applications. So that's Azure Kubernetes Service in a nutshell, called AKS. You can create your own VMs and create your own Kubernetes services on Azure as well, on Windows or Linux, but this is just a much easier way to go. So let's switch over to Visual Studio Code, and I will check. Let's enable null. Why not? Let's check our pods, nothing. So there's nothing in here right now, nothing up my sleeves. It's an empty Kubernetes cluster. I've already set the context here, and you can say, get logs. There's no logs yet, so there's nothing there. Absolutely nothing there. So everything is empty and ready to go. Okay. So next thing we're going to do is we're going to go out to the web and we're going to find something to deploy. In this case, I was thinking of Cassandra. Cassandra is an open source database. It's a Apache Foundation project, and it is written in Java, and the corporate custodian for it is a company called DataStax. So we can go out and get the official image from Docker Hub, and I've already sort of pre-opened that here, so we don't spend a lot of time. Let's accept all cookies. Why not? YOLO. Okay, so I could go here. This is the Cassandra Docker Hub. So this is the image that I want to deploy to Kubernetes. Now, if I want to deploy this, I can say, the new chats, Google and Bing both do this. They do actually help you. Here's some ways to do it. I didn't say to deploy this yet, but it's just giving me all kinds of suggestions on how to actually deploy it, which is interesting. All I typed was installing Cassandra on Kubernetes. That's all I did, and it started giving me examples and things I could do. But I'm going to use GitHub Copilot to actually do that. Here's some documentation. So you can see all of the things. They give you a beginner's guide here, and there's several steps. There's a quick start guide. You can go through and you can get Cassandra, start Cassandra, create some files, load data, et cetera, et cetera. But we actually want to run this on Kubernetes. And if we go to the Kubernetes documentation, here's an example of deploying Cassandra with a stateful set. And they have a way to do that. They have the deployment manifest here. But you have to do everything sort of manually. And there's a lot of things you have to customize in this stateful set deployment manifest, and a couple other things you need to do as well. As you can see, it's quite involved, so it's a lot of steps to do this. I just want to get Cassandra up and running. So in the world of AI, how do I actually do this? Okay, here I'm back into Visual Studio Code, and I'm going to invoke GitHub Chat, which is over here. I can also open it by saying Control-Shift-I, and I can ask it questions up here. How do I deploy this to Azure Kubernetes service? Now I'll just put the link that I copied. Okay, let's see what it says. Okay, so it knows that it's Cassandra Docker image. And it tells you to follow these steps. Create a Kubernetes deployment configuration file YAML. File describes the desired state for your application's deployment, including the Docker image to use. Apply the deployment configuration using kubectl deploy. Kubectl apply. And create a Kubernetes service to expose the deployment to the internet. Yep. Okay. So here's the pseudocode for this, but it's not actually pseudocode. I'm just glancing at it really quick. This will actually work. So then the next question is, how do we actually, it answered the question. So create the deployment configuration, create a service to expose the deployment, check the service for an external IP, and then deploy that as well. Okay. All right, so let's see if this works. Let's go ahead. First thing I'm going to do, so I like this. One of the cool things about this, I'm in an IDE, right? So you saw Bing over there starting to provide answers for me, but then what do? I have to cut them, paste them, run them somewhere. I've already set the context in this IDE, so I've got everything set up for myself. And I can do a couple things here. I can copy this. I can insert it into the terminal, which I don't want to do, or I can insert it into a new file. So there we go. So now we have a new file, basically. If I go up to the top of the chat, but I don't want this one. Actually, I want the one here. Let's see. I'm looking at this. All right. So this is the cool part is I didn't expect any of this. And by the way, every time you do something on AI, it can be different. So I want to make sure that everything's going to work here. And that's actually a good mention. This is a good time to mention this. AI, is it going to replace developers or IT personnel? Maybe. Basically right now, though, you need to know if this is real and if this is going to work and if it's secure. AI won't tell you that. You need to have experience to be able to do that. So AI at the moment, in my opinion, is a very useful assistant to help you build things like this. Anyone who's trying to create a YAML file to deploy something to Kubernetes or something else knows how hard that could be. You know, you get the spaces, you get the tabs, you got to format everything just correctly. It just generated this for us, and we can just copy it and use it. And then I can create a new file from it. So it's very, very cool. And but it's still not going to replace a developer who actually has to do the job. So let's just go ahead and let's move this chat. We'll put this over in the chat view because we're going to refer to it later. And we'll open up this chat view a little bit and we'll get rid of this Explorer view because we're not really using it all that much. There we go. That looks better. All right. So this is my new file and I can say save as. And it's going to save it as a YAML file in my GitHub local. Blah, blah. Let's save it in my LangChain for J examples. And let's just call it GIDS. GIDS deploy YAML. All right. So now we've got this file here, GIDS deploy YAML. And we're going to use these commands that it gave us over here. Let's expand that quick. All right. I have to change the file name, of course. But if I go over here and I say, well, oh, well, that's another thing you can do. So, I can open the chat in the editor. So there you go. You can move it all around, as you can see. It's kind of handy because what I want to do now is I want to copy each one of these and I can insert this into the terminal. Right? Oops, didn't go. Okay, great. Let's copy it. It's easier. All right, but I have to change something, don't I? It's not called Cassandra deployment YAML, it's called GIDS deploy YAML. Now, you notice there was a container registry there as well. We could also push this to container registry and have that automatically update. But then for the purposes of this demo, it's probably easier just to go this way. So now, if I say get pods, hey, we got a pod running. So Cassandra is running. We successfully started it. Pardon me. And we can say the logs. Let's see if this is running. Yep, there it is. So it's running. It's sitting there, but you can't access it yet. So the next thing we need to do is we need to expose the deployment to a load balancer called Cassandra service. Let's do that. Oh, you see what it did though? I did something dumb. Oh, it is called Cassandra deployment. Never mind. Inside of this, it is called Cassandra deployment. So that works. I thought I had to change it to GIDS deploy, but I didn't. All right. Next, once that's done, All right. So the next thing we want to do is we want to go in here, get the service. So once again, I'm going old school here, but copy. Okay. So there's no external IP yet, but you get the idea. Actually, I'm going to kill this because it's very, very, very insecure, as I mentioned at the beginning. So you don't want to do this. You don't want to deploy this out like this. It's exposed to the world. There could be hackers trying to pick at it right now. So let's just delete. And the Microsoft Security Copilot is going to start bothering me in a minute anyway. So Control delete. Okay. All right. So let's delete that. So that is one way to do that. Okay. So there's nothing there. So next, what I can do is I can go back here and I can say, how could I make this deployment more secure? Those of you who worked with Kubernetes and Cassandra in the past are probably freaking out when I did that. Don't worry. We're going to do something slightly different. And it's going to give you examples. Let's see if it gives me the answer I'm looking for. I don't think it will. I think it's just going to give me some. Yeah. So what it did is it actually just gave me examples. So to make your Cassandra deployment on Azure Kubernetes service more secure, you can consider the following steps. Use a private network, use network policies, use Azure private links. These are all good, but that's not what we're looking for. Use Azure role-based access control for Kubernetes authentication. This is in case you need it locked down internally. But what about locking it down from the public? So here's a sample YAML for more secure deployment. It's not really that secure. So would deploying Helm chart make, I have to lead it on a little bit here, this more secure? I don't know if I agree with that. It says deploying Cassandra with the Helm chart doesn't inherently make it more secure, but it can make the process of securing your deployment easier and more manageable. Yes, I agree. Yeah, that's the one I would use. Bitnami Cassandra Helm chart includes optional pod security policies that restrict the capabilities of Cassandra pods, reducing their attack service. Yes. Okay, so it's set up here. Doesn't make it more secure. That tells you all the ways it makes it more secure. That's what I'm talking about. You need some experience here to make sure that you're not being led astray. So the first thing you would do is add the Bitnami repository to the Helm. I've already got this because I use this once in a while. So let's go here. Oh, never mind. I'm trying to copy this. It's copied. It put everything in the one file, so I couldn't do it that way. But let's do this. Helm repo add Bitnami charts Bitnami. It will update if there is anything. Okay, good. And then Helm repo update. That's a good one. Never can have too many updates. Uh-oh. Oh, okay, good. All right. What is that though? Why wouldn't it? Oh, that's a local host. Never mind. Of course, the local host. I don't have Docker running locally, so it's not going to work. So, but it did go out and get the updated chart repository from the server, which is what it should do. Okay. So I can say Helm install. And it's going to use the current context to install this onto my okay. And there it is. It started up. and it actually fired up. And yeah, now when we check the pods, it's there, it's running, it's slightly more secure, and it's operational. So that's basically in a nutshell how you would um, create a more secure deployment of Cassandra. The, the demo I wanted to show you, and this is AI, it can be capricious, is usually when I ask it how to make that more secure, it says, oh, just a suggestion would be using a Helm chart. This time it gave me a bunch of suggestions for locking down my Kubernetes cluster internally, but it didn't give me an option for using Helm. I had to sort of nudge it in that direction. But once I did, it created it for me. It gave me the commands I needed. So if I didn't know anything about Helm, I could have this up and running, in about 5 minutes, and the other one up and running in 5 minutes as well. So if I wasn't talking to you and showing you how to do it as well. So this is kind of a cool thing. So I went out to the Docker Hub. I grabbed a reference to Cassandra. I said, how do I deploy this? I deployed it once. Oh, we'll do control get pods or control logs. I don't know why I do this instead of typing. Why do we all do this? Let's just... Do you guys do that as well? I do. So instead of just typing control logs, I'll do the up arrow 74 times to get to the thing command, and then I have to change it anyway. Anyway, there we go. So it's up, it's running, and if I want to delete that, well, I can shut that down as well. Let's ask, how would I delete this deployment? Yeah. Oh, okay. So it's the control delete service. Okay, so it's the same one. Yeah, it's called Cassandra service. So I just say control delete. I did it again. And it's called Cassandra service deployment. Ugh. Cassandra service. Oh. Okay. Yeah, it actually gave me the command and I ignored it. Control delete deployment, Cassandra deployment, but that's not the one. So it's called, anyway, we deleted the service. So Cassandra service is deleted. And we should say, oh, so there, I deleted the service, but not the pods. I can't remember how to do that right now, but anyway, you get the point. So there's all kinds of things you can do. It sort of helps you, stands over your shoulder, watches you, helps you build these things. We're running out a little bit of time, so I do want to show you one more thing before we get going there. So what we're going to do with this is actually a little more complicated than our Cassandra example. We're going to use something that deploys a backend database, front end, and it's a Jakarta E server. It's secure. It's got all kinds of things built into it. And we're going to use an item in what's called the Azure Marketplace to do that. So I'll step you through that right now. Let's go back to the Azure portal. So here we are in the Azure portal. Actually, there we go. Want to go here? Nope, I actually want to go there. AI for Kubernetes. There we are. Okay, so we covered this now. This is the deployment for Cassandra. Down here, I've actually created a new deployment that has a public IP address, Kubernetes service, container registry, application gateway, a key vault for storing secure information, a SQL server for storing data in our application, and Azure load testing for managing loading. We can actually test out activity that runs on the server before we deploy it. There's a couple other things as well. Of course, a SQL database, network security group, and a virtual network. The SQL server and SQL database kind of go together. They're storing the actual data in this database. This is the server that it runs on. Okay, so how do we actually create this? Well, I can go here and say WebSphere. And if we go to the marketplace here, there's multiple different offerings. But the one I want to use is IBM Liberty on AKS. And basically, this uses something called the WebSphere operator that we've worked with IBM to build. And it basically simplifies the deployment or management of everything. As it says here, the following resources are automatically provisioned: the Kubernetes cluster, the container registry, the Liberty operator, the Azure application gateway instance with a public IP address, sample getting started application, and I'll show you that in a minute, and custom application deployment, a virtual network, and a network security group. This is very cool, and there's a whole bunch of different things you can use as well. But if I create this, this is my subscription. I can say create a new, and let's call it GIDS. Let's copy that because we're going to use that in a few places. Okay. East US is the location, but we have multiple regions we could actually run this in. And this is where you're actually going to install the underlying resources, including the Kubernetes cluster and the container registry, et cetera, et cetera. All right, so next, we're going to do load balancing. Do we want to create a new cluster? Yes. The virtual machine size, this is interesting. You can create either CPU virtual machines or ARM-based virtual machines as well to run underneath this. The advantage of the ARM-based is they save a lot of energy and they cost a lot less. So we have a couple of different options for you to do that. Then you set your minimum and maximum node counts for the default. You can scale after that, of course. And then do you want to create a new Azure Container Registry instance? Yes. It's automatically actually going to link that instance of ACR to your Azure Kubernetes cluster as well. The advantage of that, so our Azure Kubernetes our Azure Kubernetes registry, if you can hear my voice is getting a little hoarse, is based on Docker. It's based on the Docker Hub that you may know and love. And Docker Hub is open source, and we've implemented a version of that. It's by default private. And when you create a resource, it automatically, in this case, links it to your Kubernetes cluster via some authentication. Obviously, you don't want just anyone being able to post to your Kubernetes cluster or your container registry. And this just provides a way of documenting and managing the repositories that you're going to be deploying out to your registry, out from your registry to your Kubernetes cluster. Do you want to connect to Azure Application Gateway? Yeah, we do. You can generate a self-signed front-end certificate, or you can download your own TLS or an Azure Key Vault. So the advantage of Azure Key Vault is it stores all the keys for you, internally secure, and you can delegate who has access to those keys inside of your organization. Is this IBM supported? That means, do you have a WebSphere license? You choose yes if you do. If you're going to use Open Liberty, or if you don't have a license, you say no. Deploy an application. Yeah, we're going to deploy that sample application. You can choose your own application, or you can use the sample app, which I'll show you in a second. And you can auto scale the replicas. If you go over 80% CPU, it'll add another replica up until a maximum, et cetera, et cetera. We'll say no for that for now because this is a demo. All right, so it's going to check all this, see if we passed our validation. We're not actually going to run it anyway because I've already created one that I showed you earlier. Boom, boom, boom. But anyways, taking a little, oh, there we go. So everything passed. It's okay. Gives you a summary here, and then I can click create here, and it's actually going to generate this custom image for me automatically. But we already have one, so let's just go back there, and I'll show you that one. In this case, the Kubernetes service is here, and it has its own ingress, the ingress itself. If I look over here in services and ingresses, you'll see that there is a, oh, no, wait. We're using a public IP address for this one. So let's go back to the dashboard. Oh, I'm looking at the wrong one. Never mind. But the public IP address is here. I can use that public IP address. I can copy it. I can open it. And this is what the application looks like when it's deployed. It's a simple CRUD application. It's running on Jakarta EE. And I can say latte. Let's create a new latte at a price of $10. And I can submit it. Oh, doesn't like the $sign. There we go. So you get the ID here, latte, price, and you can delete it. So simple CRUD application, create, replace, update, delete. That's the end. So that's how you actually create that. It's another handy way to build these things. So what would you do with AI in this case? I haven't shown you anything to do with AI. Yeah, so if you're going to build something with AI like this, you could update your application. You could customize the Kubernetes. When you actually build this, there's actually quite a few involved steps in, let's see, open recent. Where is that? Here it is. Okay, so there's several steps you have to go through to actually manage and run and deploy this once it gets running. So you can do things like ask it how you would find a pod and tell it what the pod names are and ask it to basically monitor these and tell you how the application could be improved. That's the kind of thing you can do with the AI in this particular case. The deployment itself is handled by the operator and by the process that we have for deploying that. But improving that deployment is where you would actually use that and import and manage the service itself. So that's kind of cool as well. Let's see. I did want to wrap up with some let me get over to the slide deck. I did want to wrap up with some responsible AI. This is something we like to mention as well. It's a feature that we have, and plus it's a great thing to share with the community in general. So in 2016, Satya Nadella produced an article on AI design principles. We adopted all those principles in 2018. OpenAI really didn't start until around here, so we've actually been working on this for a while. Facial recognition principles were adopted, making sure that, I'll show you the principles in a minute. And then responsible AI standard, V1 was in 2019, and a strategy in engineering was established. And then we have a responsible AI dashboard and a new standard for responsible AI as of 2022 as well. These are the principles that we adhere to at Microsoft for responsible AI. Privacy and security, inclusiveness, accountability, transparency, fairness, and reliability and safety. And these are built into all of our tools, training, rules, and governance. So what does that actually mean? AI must maximize efficiencies without destroying the dignity of people. AI must guard against bias. It needs accountability so humans can undo an unintended harm. Something might happen, but let's make sure we can fix it. AI must be transparent, meaning that we need to know where things came from and why the results turned up the way they did. AI must be designed for intelligent privacy, meaning you don't want to share too much. I shared the example earlier of my itinerary. coming to Bangalore. I don't want to share that with the world, but I would like to use that as part of my queries. So that's important as well. Whoops. Lost it there. There we go. Also, it must be designed to assist humanity. Let's hope it helps and doesn't harm. Absolutely. So just in conclusion, using AI to deploy Java apps to Kubernetes. Thanks for hanging in there. Once again, thank you very much to the organizers for allowing me to do this virtually. You probably heard in my voice, it keeps coming in and out. I hope this was useful. Thanks for the flexibility. And please do provide some feedback. I'd like to hear from you. I'm on all the socials. Find me on LinkedIn as well. Link to me on LinkedIn, Brian Benz, Microsoft, and B Benz on all the socials, including GitHub. Please do follow me, find me, and connect with me on those. So thank you very much. There's some links over here as well for Microsoft.com Java. It's everything we do. GitHub Copilot, the AI that we have learned at Microsoft.com. Resources for GitHub, and also cognitive services for data privacy is a great coverage as well that you can actually reuse and adopt in your own organizations. Thank you very much.